Thank you, and welcome everybody. Super excited to be here with a bunch of super esteemed friends from industry and the panelists here. We're gonna go through talking about a topic that's probably top of mind for a lot of people out there, like how are the hackers evolving in these times with artificial intelligence, advancing of all kinds of technology, getting better and better, and really exploring a little bit on what do we see on the bad side, or what are the hackers up to, and how is artificial intelligence kind of driving that change possibly. With that, I want to go through introductions briefly. I'll just start it out while I'm talking already. My name is Raffael Marty. I run research and intelligence for a security product company called Forcepoint. We're a user and data security company. We are basically focusing on the intersection of users and data and understanding what is the behavior of users that is normal and how do they interact with their data, and basically applying sort of a human angle to that and understanding what is normal human behavior. And with that, we're really trying to escape this cat and mouse game that you're seeing in security, where the security industry is putting out a certain trap or a defense. The hackers are climbing that and somehow evade it, go around it, find other holes, and then the security industry puts out something else that's preventing that, and it keeps going. And so really we're trying to escape that by using behavioral approaches to do that, which is really, I think, topical for the panel here, because we're using a lot of advanced methods in order to understand human behavior. So I lead our research and intelligence. So that means all the different protection methods and the approaches we're using in our different products to do that. We have a number of researchers that are working on human behavior intelligence. There's a psychologist on the team helping us understand humans. So pretty interesting team that I have the honor working with here at Forcepoint. My career, I've spent the entire career in cybersecurity, been very fortunate. I've worked at IBM Research a long time ago back in Switzerland where I grew up, then moved over to the Silicon Valley, worked at ArcSight very early on, went over to Splunk when it was still a very small company, helped them setting foot in the security market, worked on a lot of use cases there. So I spent a lot of time with customers and companies out there trying to understand what are they trying to solve in cybersecurity, and helping them with data analytics tools getting to those answers. All right, so that's a little bit about me, and I'll hand it over to Anna to give a brief introduction.
Hi, Raffael. Thank you. And I'm very excited to be joining the seminar. So hi, my name is Anna Trikalinou. I work at Intel and have about 10 years of experience in the cybersecurity domain. My work is both offensive and defensive, and I think that will be interesting for the panel to talk about. So on the offensive side, I have done some really exciting work. I've discovered a new DMA attack that allows an attacker to both get secrets from a victim without the victim knowing, but also modify the victim's memory so that it can put malicious data for the victim to consume. I've also done work on side channel attacks. I've discovered a new side channel attacks on DIMS. I've done work on raw hammering, and I've also worked on the defensive side as well. So what has been my main focus right now is designing and architecting a new VDD extension to allow for secure communication between a host CPU and an external device. So it is a little bit broad, but I'm excited to talk about it.
That's awesome. You have really broad background. It's going to be interesting to hear your opinions on some of these things. So excited to have you. Continue with Charles.
Hi, good morning or afternoon as the case may be. My name is Charles Givre. I'm a data scientist. I work at JPMorgan, where I'm currently a product owner for data analytics. My background, I have a pretty diverse background. I got into cybersecurity about 5 years after I left grad school, but I was always kind of doing technical work. I worked for Booz Allen and various government contractors, various government agencies rather. And I've been kind of in the last few years working on I guess the intersection of big data and cybersecurity, and kind of working with analytic tools to help people get data and analyze analyze it easier and faster. I'm the project management chair for the Apache Drill project. I wrote a book for O'Reilly about that, and then I also have a data science training company called GTK Cyber, where I've taught cyber data science for some time now.
Awesome, cool. I'm excited to hear your thoughts on the whole, how is data changing the game for the hackers also. But maybe let Dhia introduce himself quickly as well.
Yeah, thanks. So first of all, it's exciting to be on this panel. So thanks for the invitation. Let's put it this way. I started in cybersecurity in the late 90s, playing with, hacking tools like Nmap and Snort and Nessus. And then I went on to do after my engineering diploma in cybersecurity and computer science, I did a master's degree and then a PhD in graph theory. And then I joined OpenDNS as the first senior researcher back in the day. And we built the product, and we ended up being acquired by Cisco, since it was a fun and awesome experience and adventure. And now I'm running the research team in Cisco umbrella, where we basically build the algorithms and the systems that power the threat intelligence behind the product. So a lot of it is large scale data analysis, finding the patterns, behaviors of attackers, and then enforcing the protection for our users around the world. So that's kind of in a nutshell my journey.
You're still using data visualization for any of the analysis?
Sometimes, yeah, when it's useful and when people kind of want the wow effect.
Awesome, yeah. I've crossed paths with Dhia in the past, where we talked a lot about data visualization, and actually the team built a really interesting data visualization tool to visualize different interactions and different properties of the data that they had in these amazing 3D visual graphs. And I encourage everyone to go and check that out. All right, with that, let's jump in here and look at some of these questions that we have for you guys today. And I want to start with probably one of my favorite questions whenever I'm on a panel or even when I give a talk these days. And that's really, how do you define AI, artificial intelligence? Because I hear a big, wide variety of how people define that. When I started 20 years ago in this industry, we didn't call it AI, we called it statistics for most of what we did. And it's still, the methods have not changed that much. And we called it lots of data. We didn't call it big data back then. But maybe want to start with Giles. How would you define sort of AI in this realm of also the hackers and the cyber adversaries?
Sure. So thanks for the question. I think, so I've heard, I'll just go with simple definitions. I've heard a definition of AI as any technique, any computer technique that mimics human behavior. And maybe that's overly simplistic. Within that, I've heard, I define machine learning as basically a technique that learns from past experience to, I had a really good definition for this, and my mind is totally drawing a blank right now. But the essential idea is that machine learning algorithms learn from past techniques to generate instructions so that the computer is learning. Sorry, I'm circular. Circular definition there. So that the computer is kind of figuring things out. The key is without being explicitly programmed to do so. So what that means from an adversarial perspective is that malicious actors can develop automations and scripts and tools that can be more reactive and can kind of learn from our defenses and react accordingly, and without having to have a person manually changing things and doing that. So you can get more adaptive attacks than just a static, a statically coded, script, basically.
Yeah, interesting. I'll ask in a minute, sort of how we're seeing that in the wild, but I like that definition, right? Like sort of what you said is like the algorithms don't have to be explicitly told, and then in these scenarios, really going after sort of learning what's happening and the adaptive piece. That's interesting. Anna, maybe how do you think about this?
My idea is that AI has been out for a while, right? And we have been studying that for 40 years now, but it has mostly been heuristic based, like a star, try to find something, like in a complex system or in a complex tree. But I think the big boom that happened with AI is machine learning and trying for the computer to try to learn from past experience in order to become better. So for me, AI is mostly around that aspect, I think, and trying to use attackers try to use AI and machine learning on trying to find, let's say, vulnerabilities automatically, not with just fuzzing that we had in the past or symbolic execution, but with more sophisticated ways.
Mm-hmm. Mm-hmm. Awesome, great. Dhia,
if I could just add one thing. One of the things that I think you kind of touched upon in your introduction to this question is that many of the techniques, we used to call this statistics. With a lot of the machine learning algorithms that exist today, if you look at them, many of them are derived from mathematical techniques that some of them can even be hundreds of years old. What I think has changed is our ability, first off, the ease of which to code these algorithms has dramatically improved. And then also our ability to process massive amounts of data using algorithms that are not computationally efficient. Has that basically being able to do those two things easier has made AI or machine learning much more accessible. And so you will see people start to come up with much more creative uses for it.
That's a good point.
Yeah, totally agree.
Dhia, how would you define the AI in this context?
So you want a definition of AI or a definition of AI in the context of cyber adversaries? So I'll start with, yeah. So I'll start with like my perspective. So I'll move away from the formal definition since both Anna and Charles gave like good ones. So to me, like AI is actually mainly two things. It's a problem solving paradigm, and then it's a tech. So the problem solving paradigm, like Anna said, existed for a long time. It's being called like stats. It's being called math. It was called algorithms. Then people call it machine learning, and then they call it deep learning sometimes. And then you can call it graph theory and so on and so forth. Anomaly detection. You have like so many different disciplines that fit in the AI, I would say, bucket. So that's like one thing. The second one, it's a tech, meaning AI became important and talked about when the rise of the CPU, RAM, storage, and networking, or I would say bandwidth, became very powerful. And in a sense, when those things became such a commodity and they are in abundance, then we were able to have AI at very large scale. So that's kind of a couple things I can say. The other thing, AI, some very key requirements or features about it is that it's about automation, scale, and then it's leveraging data, as opposed to the algorithm design we learned in our CS major, where you have to write the logic yourself in the code. So it's a bunch of if-else statements, switches, reading data, processing it, outputting it, so on and so forth. Whereas in AI or machine learning, the data itself and the environment gives you the seed and the meat to work with. So that's kind of the perspective I have about AI in general. In terms of adversaries, maybe we can touch upon those later. So I'll leave it at this.
Yeah. It's interesting what you said. Like you kind of honing in on the data conversation, and I would actually challenge you a little bit that I think some machine learning algorithms are based on the historical data, right? Like if you look at machine learning, but I think this is also a little bit of a sickness in the industry. We keep looking at machine learning and think that it can solve all our problems, but there's things like belief networks or such out there that are really they're capturing expert knowledge without even historical data, right? A priori, like I put the knowledge in there, and then maybe I run a machine learner over it to optimize the graph there. And maybe that's going to come in some later discussion also. But just want to highlight that a little bit. So let's move on to the second question. Now that we talked a little bit about what AI is, how have you guys seen that the hackers are applying these methods, or have they changed the way they're doing things by maybe, I don't know, back in the day, just attacking any host on the internet, scanning and whatever, wherever they find port 135, they go and attack it. Are they using artificial intelligence today? And how are you seeing that being used? Maybe start with Dhia this time.
Sure, thanks. So maybe, yeah, I'll jump on the thought I had in the first question then. So in terms of, if we're dealing with AI and adversaries, I can break it into two things. One is how to divert the existing AI to make it harmful. So in a sense, like we said, automation, scale, and data. For example, you have a lot of open source data nowadays. You can go scrape the web. You can download like some massive scans of the internet. You can download routing tables. You can download all kinds of interesting data sets like TLD, zone files. And then as an adversary, I can go and use like algorithms and maybe some machine learning methods to find the vulnerable hosts, let's say WordPress hosts, that are the best for me to attack and leverage for either like cybercrime or APT attacks. So that's like one aspect. And then you have, so I would say data collection and mining, attackers can leverage that the same way we leverage it for good and legit purposes. And then you have all of the, so my first, I would say, class of adversary and AI would be the misuse of AI. So for that, I'll enumerate examples like the data mining for harming like others. There's also surveillance. So you have like a lot of governments and, you know, the Snowden like whole controversy, how you had governments like spy on their people. You have also governments using some sophisticated methods to, let's say, go after activists or minorities. There's also disinformation. So again, disinformation is becoming like more and more important and very problematic nowadays, from the elections to in the US and Europe. So you can use like the bot farms, the data sets in the case of Cambridge Analytica. So that was, again, it was data that people thought was just like harmless, and we wanted to share our likes and friends, and now people are leveraging it for malicious purposes. And then I can also think of automation in malware. So botnets, for example, you can control them remotely, and you can give them some sort of intelligence in a sense to kind of group and regroup and split and change behavior. And so I'll stop there on the first class of misuse of AI. The second one would be how to attack AI itself. So you have a lot of cybersecurity products, whether it's AV engines, whether it's like DNS-based, proxy-based, firewall, and all of them have the AI embedded in the logic to make decisions. Well, you could actually attack them the same way you attacked other systems. So you could try to find a malware that will be FUD, meaning the AI will not detect. You can fuzz the system to see when it makes mistakes. And with the input I gave it where it made mistakes, now I can say, actually, the system, the AI system did not recognize this profile. So I'm gonna replicate it and reuse it again to lure it and make it like fail. And then you can also use...
as seen in recent examples of a very famous endpoint protection company that someone found how to circumvent it by adding a little bit of a string at the end of the binaries that came from gaming binaries, basically, right? So yeah, very, very good point.
Absolutely. So then maybe I'll add a couple thoughts and I'll stop so I don't hijack the whole conversation. But the last couple thoughts is, for example, the let's say I'm thinking specifically about WAF and DDoS mitigation. So those learn from data on the fly. So there's like an online perspective or component in there. And they tend to be vulnerable because if I keep feeding you like some behavior slowly, I'm gonna shift your prediction to something I want. It's almost like I'm hiding in the crowd by making you think that whatever I'm doing now is actually legit, even though I'm trying, let's say, to knock some ports, or I'm trying, let's say, to inject like some malicious traffic or SQL injections and stuff like that. So again, to summarize, it's like the misuse of AI, and it's also attacking the existing AI.
That's awesome. Great. I saw Charles nodding a bunch there when Dhia started talking. Do you want to chime in on some of the things there? You're still on mute in case.
Sorry. Yeah, that was very, very thorough response. Yeah, I was thinking, kind of the response that I took down 4 categories. And Dhia really covered it well. Smarter reconnaissance, like you can, if someone is building something to automatically scan networks or IP spaces, they could use past their own past experience, past others, to build a smarter scanner that can hone in on perhaps unidentified vulnerabilities or anything like that. Attacking models. This is something that I think is a very interesting area. And I read there were a slew of papers that came out between 2016 and 2018. And I haven't been researching it, but I haven't seen much since then. But this is a topic that's very interesting to me. And I feel like this is something we're going to, as more models get introduced into more and more critical systems, I think we're going to see more and more of that, attacks against machine learning models. And the example in the paper I saw was that somebody did some research, and they had a very well-trained model that could identify road signs. And by strategically putting pieces of tape on the road sign, they were able to get completely erroneous classifications or identifications. So you could imagine, if this model was being used in a self-driving car, the implications of something like that. So I think there would be more and more things like that. And then, of course, deep fakes was another category that kind of falls into that. One of the historical examples of AI kind of being used for attack, I read, I think, what is it? It's the worm. It's about the history of the Conficker worm. And it used a technique called DGA, domain generating algorithms. And the first ones, it's a great problem actually to teach machine learning to newcomers to it. But the essential idea is you have on the bots, you have the bots that get deployed, they have a random seed and they generate random algorithms that are in sync with the command and control server. So the first generation of these random strings look like just garbage, just gobbledygook. As more and more ML models were deployed to detect this kind of activity, the people developing the botnets came up with new algorithms that used dictionary words. So it became much harder to detect DGAs from with like that versus the random strings that were generated. Oh, one other thing. Sorry, I my notes here. You mentioned the kind of the world seems to have gone through this phase of putting out all this data that was believed to be innocuous. I gave a talk 5 years ago where I took data that I gathered from a whole bunch of IoT devices in my house, and the point of it was to demonstrate how seemingly innocuous data is actually, when viewed in aggregate, can actually be very, very invasive and very revealing about a potential target. If anyone's interested, email me afterwards. I'll send you a link to it. But, yeah.
Awesome. Thanks, Charles. Anna, any thoughts on the topic?
Yes, I just wanted I want to mention the self-driving cars as well, but Charles already covered it. I really had the same, I read the same study and the same work, because we really don't like it when our computers crash because of a DOS or a DDoS, but we really, really will not like it if our cars crash because of a malware, right? So I think that is finding new use cases where machine learning is going to be used is going to be great, right? But it really opens new avenues for attackers to hack it, right? Yeah. So that was one aspect. The other thing that I just want to add, even though Dhia and Charles did a magnificent job on covering this whole the question, is another work that I have read regarding side channels, where they used machine learning in order to recognize the patterns of that another application is generating as a footprint on the cache, and from that they could recognize what is the other application that you're running, what is the key, what is the encryption that you're using. And they could even extract a whole YouTube video just by looking at the footprint that that YouTube video was living in the cache. So I think that was kind of impressive.
Interesting. Yeah, I think we all agree that how hackers are using AI is a lot of automation, right? In all kinds of different ways, as you guys were outlining, from the recon to even like finding vulnerabilities or like the side channel attacks by even looking at memory and not just necessarily on the network, but all these different channels and sort of the capability to analyze large amounts of data, as someone was mentioning it as well, right? Like over time, we got this capability to now easily apply these algorithms, have large compute to analyze things, and hackers have access to that as well. I mean, the cloud infrastructures, they can spin up 1,000 instances and then look at something quickly, do some brute force or some analysis. It's definitely sort of, I would say a lot of what you guys have mentioned falls into this automation side. Now, having talked about some of these, do you think that, or have you seen that hackers, criminals, nation states, crime groups have actually changed their way of behaving in the last, I don't know, maybe 5 years with using these new AI methods? Or are they still using the same things that they have been using? I'm thinking specifically about organized crime, where I'm buying a botnet or I'm buying credit cards or something like that. Are those guys now using AI to make their operations more efficient? Or how else are these guys changing their methods? Maybe starting with Anna this time.
I definitely imagine that any organization, either criminal or legitimate one, would want to be more efficient. And AI can do that for you. It can find vulnerabilities faster for you than any one employee can. So I don't see a reason why they would not. AI is a tool, and it's a really, really good tool for both good purpose and bad purposes as well. So I don't see a reason why they wouldn't switch to that.
Okay, Charles?
I personally haven't seen that, other than the kind of aforementioned botnets becoming more and more sophisticated in their use of that. But that's not really been my area of kind of research and expertise. So but I would agree with what Anna said. I'm sure they're out there and using it, and why not? Mm-hmm.
Dhia, do you maybe have an example? Because I actually got a question from Candid. Hey, Candid, about whether you guys have a real world example of where hackers really used AI instead of just like simple automation. It's sort of a variant on this question, but I think it's going in the same direction. Have you seen anything like that, Dhia?
So it's a difficult question to answer. Why? Because whether we have systems we use for defense or the system used for offense, like the malware and whatnot, they're black boxes unless you go and basically decompile it or see the code. And AI, if you look at an assembly, it's gonna look as just like assembly. So you cannot tell if it was like a random forest, a deep learning system, or like a clustering algorithm. So, but then how can you find out if they're using AI? Well, you'll have to use human intelligence. You'll have to go into forums and see if they're discussing, hey, have you read this paper to do, let's say, a better email to lure like a bank or like get someone to type in his credentials. Mm-hmm. So that's kind of a thought here. The question is worth asking. But again, I go back to what Anna said. AI is a tool. And the analogy I use is, since it's like the stuff I work on, like DNS and hosting and cloud, think about its history. So domains, registration of domains started in the, I would say, mid-80s, late 80s. Hosting emerged in the mid-90s. And then cloud started emerging in the mid-2000s. And then between 10 and 20 years later, we can see that these techs are being highly weaponized for attacks. These are not AI, but these are techs and tools. And you still have the component of skill and automation in them. So now you project yourself, whether it's happening now or it's going to happen in 5 or 10 years, when AI becomes a commodity, when everything that we use becomes AI powered, actually, I don't care whether it has AI or not. As a hacker, if I know that my device, my mobile, has facial recognition, it can generate like some deep fakes. It can fuzz like a million different devices. It can do like so many different things that are powered by AI or ML. Like I said, I don't care what's inside. I can weaponize that. So imagine in the future, you might have Trojans actually that are installed on a mobile that is AI powered. Imagine also Intel actually, or AMD or NVIDIA will build, if they're not doing it already, like an AI powered CPU or GPU. And then a hacker can use that either by buying it and having it in his own like device at home, like it's, let's say, a server, or he can use a cloud service who is a AI powered GPU or AI powered CPU instance. You know what I'm saying?
Mm-hmm.
So I guess to summarize it, to answer the question, have they been using it other than automation, like for botnets or crafting like more sophisticated emails, crafting more sophisticated exploits, so on and so forth? Unless you have a real human chat with some of these actors, or maybe if you uncover, let's say, an APT campaign where we end up finding that actually a nation state was weaponizing AI, I'll just say possibly. So that's my honest answer.
Awesome. No, I like that a lot. Thank you for that. So we looked at sort of the hackers, right? The guys trying, or what we're talking about, like using AI and attacking our systems. Now, if we turn this around and by looking at the security products out there, the way that companies are protecting themselves by using tools, products, services, more and more you hear that these tools are using AI, right? And again, for whatever definition of AI, let's just assume it's something smart. Now, does this actually put us as a disadvantage because we're now using AI? And we just talked about, you guys all mentioned these vulnerabilities, right? In like adversarial AI that are just being used to crack some of these things. You mentioned fuzzing there to figure out what the AI algorithm is doing. By using products with AI, is there a disadvantage that we're running into from a defense side? What do you guys think on that? Dhia, any thoughts on that? He's trying to get unmuted. Maybe Charles, if you want to go first.
Yeah, I was muted. Go ahead.
Oh, okay. My initial thoughts when I heard this question is are more almost psychological than technical. I mean, I think, you know, as Dhia was saying, as any technology gets rolled out, basically, you know, the bad people are going to find a way to use it to do bad things. And, you know, we see that with cloud technologies, we see that with all these different things. What my concern with the application of AI is the overhyping, and I would say the lack of just general understanding of what the real capabilities are will lead, could lead organizations to be overly confident in their defenses, and then also not understanding that, you know, these AI is not, machine learning algorithms and models can be attacked, you know, the same way as different techniques, but they can also be attacked. They're not invulnerable. And my concern is that organizations don't really understand how these things work. Combine that with a lot of hype from vendors. Combine that with, you know, it could create this storm where people think their risk is a lot lower than it actually is.
Oh, great. Anna?
I don't think that having AI makes something inherently more insecure or more vulnerable. I think if something is connected to the internet, this is a big factor for making it a target for exploits.
Yeah.
If something is complex, this is another factor for whenever something is complex, there are going to be bugs no matter what. I think those are the two factors that make something more vulnerable. I don't think it's AI itself. And we've seen, for instance, the Ukraine power grid hack. That didn't have AI. It doesn't need to have AI for something to be exploited. So I think I agree with Charles. It's just a little bit of a marketing trick.
Yeah.
Yeah, actually, both answers are super awesome. So I have a couple thoughts on this. Historically, so you're saying basically, is claiming to use AI or using AI is a disadvantage? Well, look at the security industry or the products we've had for the past 20 or 30 years. We had what? AV, we had firewalls, IDS, proxy, so on and so forth. In the early days, AV was signature based, and then we found out it's junk. So meaning now what we claim is being AI powered now, in 10 or 20 years, we'll find out it's actually junk. So that's like one aspect, meaning our answer now will change in the future because we'll learn better ways to do things, but also we'll be able to scale it and automate it and have more quality. Mm-hmm. That's like one thought actually. Meaning like the answers will shift as we mature as an industry, and also the aspect of hype. Now the hype actually is about the lack of transparency, lack of explainability. We don't have quality standards about the training, about the predictions. So it's actually a problem in our industry. We claim to do things, but we're not creating like a common language to trust each other. So it's all based like how I flex my muscles and at RSA and how better my marketing is. And so actually it's back to what Charles was saying. It's like psychological actually. Mm-hmm. Yeah. I'm gonna convince you with my power because I can yell like louder. But then at the core, is my tech really AI? Maybe it's just like a couple of rules and if-else statements, and that's the end of it, you know?
Yeah, it's interesting. You mentioned the IDS example, right? Like where you had signatures. We actually still have signatures, and a lot of them are working really, really, really well, right? We just augmented by other capabilities as well. And then in certain cases, some people put the spin of AI around that and they're like, oh, we're using AI. But if you break it down, it's actually these simpler methods. I have a couple other things I would throw in the mix, and maybe the dangers of AI or how we could run into dangers by just trusting these products that have AI, which is explainability. And you guys talked about this, right? Like the self-driving cars is a great example. Like if I have a black box that I can't explain what that thing actually does, how it learned, how it will like react in a certain situation, that's really dangerous. And that's a topic that I think needs to be discussed more, also from the vendor side in security products. And then along with that goes something I've been saying for quite a while, which is algorithms are dangerous. And what I mean by that is, and you guys mentioned this too, I think Charles mentioned this, it's gotten very easy to apply these algorithms. You download the library, you run it on your data, and you get output. It's like, oh, here, this is malware, it's not malware. Here's an attack, here's not an attack. It's gotten really simple, and we can do this at scale. But understanding what the algorithm actually just did is not that easy. You have to understand, you have to go in, look at the code, understand the library, understand the algorithms themselves, how to set the parameters to understand what just came out, right? Charles, I see you like trying to chime in there.
Yeah, the whole topic of explainability is kind of near and dear to me. There was a paper that I read by one of the authors was Carlos Justrin, I think is his last name. They put a module on GitHub called Lime, like the fruit. And basically what this is it treats models as a black box, and it produces an explanation of how a model arrived at a particular prediction. And the idea being that you can understand, like, is the model predicting noise and it's just getting lucky, or is it actually predicting things that are, that would indicate that you should trust the model. And I use it when I teach my classes because I think it's a really powerful example. But I mean, some of the models that exist are just so complicated that they are virtually unexplainable. And this project goes a long way towards showing that. I think also, I mean, we see all this analysis right now with the pandemic and all the data that's being put out. It's like a great example of, in my mind, of data analysis kind of gone wrong. Just you can just assemble a broad swath of articles from any news source you want and just pick them apart, and you see how data can be used to for completely wrong conclusions or whatever. I mean, I'm not criticizing anyone politically here, but just there's no shortage of bad analysis with that. And the same goes with security data. And when you start introducing very sophisticated mathematical models and you don't have an understanding of what their output is, that's just not a good situation.
Yeah, and this goes to the problem of both security and data science are really hard disciplines, and finding someone that can bridge to both is really, really hard, or even harder, right? Dhia, you wanna?
I'm gonna post a link to the Lime thing in the Q&A. So.
Yeah, I was gonna. Thanks for saying that, Rafi. I was gonna echo a couple other thoughts mentioned. The explainability actually becomes a lot more relevant if you're talking forensics work. Imagine you get like a breach, and your security product claims to do the detection with AI. And they say, well, it's closed source, intellectual property. I cannot tell you how I came up with this conclusion. And they claim, well, we detected it, but something was wrong with your setting or like the way you put the parameters. Well, who do you believe? And there are like legal repercussions, insurance, even like maybe some prosecution. That's like a dangerous space, I mean, again, we can look at other industries where some high, like very strict standards have had to be enforced to be able to have the accountability and this type of kind of follow up when dangerous things happen.
Yeah,
that's like one aspect. So I want to hear your thoughts about that. The other one is privacy, actually. Are you, especially with the GDPR stuff now, and if you have a security product that is, let's say, going over data that could be sensitive or like personal, are you guaranteeing that it's following the rules,
Yeah, that's interesting. My thought on the whole privacy conversation is privacy is like security in the development life cycle, right? We have SDLC, secure development lifecycle. You build in gates and processes to guarantee the security of your products, from design to black box testing to code reviews, all these things. Privacy is exactly the same way. You have to build it in at the design phase. You have to have your gates where you test things. You have to have your process in place. You have to have the right stakeholders in place, legal and so on. To me, it's just a matter of time until it's becoming the SPDLC, right? Security and privacy development life cycle. And we just have to address it. There's no way around it. And we're going to make mistakes just like in security, but it has to be addressed and taken into account, especially data science, where we're looking at data. We have to do things with privacy first in mind. I think we're running out of time here. Sorry for cutting you off, Charles. It's 33 past the hour here. We haven't really tackled the last question yet, but I think we kind of answered it a little bit in the answers before. The question was like, how are things going to change in the next 5 years, and how are hackers going to use AI to evolve? I think for me, what I heard is really it's automation, right? In all variants of automation. It's larger scale. It's better understanding where to attack. It's maybe better methods to attack. It's easier ways for the hackers to do reverse engineering. All these areas are going to benefit from the amount of data available, the algorithms that can help them, and the scale that they can operate these algorithms on. And then obviously the NVIDIAs and Intel's not really helping because they're building better chips to do all this stuff. So helping the hackers as well, right? Obviously I'm facetious there. But with that, I want to thank you guys all for chiming in here. This was a super fun 45 minutes and reconnecting with all of you. I'm going to hand it back to Michael with that.
Thanks so much. You all crushed it, Raffael. Amazing job as always. All right, so before we end, I want to do one quick little activity where cybersecurity and AI, you got to give me one word. What comes to mind? Charles, go.
knew you were going to do that. Fast moving. So 2 words.
We'll put a hyphen in between. Dhia.
Okay.
Opportunity.
Raffael.
Complexity.
Anna.
Exciting.
Exciting. All right, good. Fast moving, complex, exciting, opportunity. I agree with all those things. All right, to you 4, thank you so much for being here. I think, yeah, I get that it's an opaque question of how are hackers using AI. I couldn't find a professional hacker, I guess, to come on here for interesting reasons. But yeah, I know it's an interesting question, and the years will tell how hackers end up using AI. All right, so to everyone, thank you for joining. I wish you a healthy and safe rest of your pandemic. And yeah, feel free to hit me up whenever. I'm just Michael at AI4.io. Always happy to talk AI in cyber or any industry. Thank you, everybody.
Thank you. Have a
Thanks
good
for
day.
Thank you very much.
Thanks,
Bye.
guys.
Bye.
Bye.